I can go through my example here, and then if you still don't see it, then we'll look at it.
The debug functionality, did you go over how to use the debugger and interpret its results?
Or can we use it?
Use it.
Is it not very useful?
I don't know.
Oh, okay.
I never use it.
Okay. All right.
Okay,
never mind
so
then.
I might take a look at it during the week, and then next, because we got another session next week.
Okay.
I don't know if it's very useful. I'm old school. I had to start this stuff before they had all these things, and so I just never used them. But I know that now people use them. I'll take a look and see if I can fumble my way through it. And that's about what it'll be, unless somebody else is, really proficient at it. You can talk to me.
It just, when you have errors, it just sometimes happens for other
Yeah.
stuff. When
Yeah.
I debug,
Yeah.
you watch them and see
Yeah.
it.
I'll take a look at it. But I'm
Well, specifically with an endless loop, I couldn't figure out exactly where it was. But I
usually
figured it
an
out
endless
eventually.
loop will be, you go look at that update statement. Because that's what happens. I'll just give you a clue. That's the way you have an endless loop, is I didn't update.
Okay.
It's almost invariable. But a good way of, I think probably a good way of debugging, and the preferred way, is what the Tia said, is put in your little print statements there. Not only that, it gives you a nice log to look at it, rather than, because usually if it's like on the Visual Studio compiler, it's pretty cryptic. I mean, you got all the variables, to me it's hard to follow, but I guess where I see it would be really useful is if I'm reading a stream in, and I'm looking at one character at a time or something like that, then it starts to look a little, maybe a little more appropriate. But I'll take a look at it out of curiosity, since it was brought up. I may still come back to it. I don't know. But we'll see. Okay, I'll go over a solution. But before I do that, I want to give us some heads up. We're rapidly approaching the end. Okay, so next week is our last formal class, and I will, tonight I'm going to cover storage procedures. Boy, getting grim. I may have to run down, get me a new one. Storage procedures, okay, that's fine. Okay, and functions. And the only thing that's going to, I want to say, error, I was going to say error checking, we'll call it error checking. Actually, we do capture our errors, what went wrong. That's not quite probably the same thing that yours is, but it's not gonna. Yours is a logic error. You'll have that infinite loop. Again, that's usually an update statement. Okay, we'll look at this tonight, and then next week I'll look at triggers, and also returning a table variable. Actually, not returning it, that's not the right word. We're returning a table from a function. Okay. Of course, we do that with a table variable. Returning the table. And
maybe.
the debug function. But one more my way to do that. Make these things out of it. So that's what we'll do. And then I'll try to have some example review questions. Example. When you come back after Thanksgiving, that Thursday will be your exam, your end of course exam. Do you have a question, Jerry? So, and I may give a little simple problem here next week. I don't want to ruin your Thanksgiving.
Uh-huh.
This year it came a week later. They squeezed at the end of the semester. It's kind of a strange deal. Usually don't have 2 weeks after that. And I give my end of course exam within 15 weeks. Because most of my classes are nights and they're workforce students. And somebody's going to get hung out to dry. Stuff. That works. Don't use that as an excuse. You check it out on that. Okay. And as I said earlier, the exam, just to kind of give you a heads up, it'll be an open book, the Mirosh book, and you can put all your PowerPoints into a little binder if you want to use that. Particularly this stuff here at the last, because that's not covered as extensively as I think we covered it. The other stuff is covered very well. Primarily for clarity. Any other questions? Any questions on any of that?
Can you put the PowerPoints out there so we can have notes on it?
Okay, I don't have a whole lot of them. Anyway, I'll do that, you know, look at that example script. Desktop. Go back. Copy. And highlight. Okay, they're in that folder. Okay, let's take a look at the ISP. And where do I have that? Right here. And I hope this is the same as what I assigned you. Quite often I make change. I had it one way at one time, and then I changed things around. And so it may not be exactly the same, but it should be fairly close. So let's go back up here at the top. I'll start here at the top. So first step was I need to declare an input record table. And what I've done here is that made that a table variable. I think I asked you to do that. If this doesn't match, you tell me, and then we'll see if we can resolve it. And you'll note I put a sequence number in there. I don't know. I think I had to enumerate that because our customers here, I kind of those are pretty uniform, but I may have jury rigged one in there somewhere. So I went ahead and enumerated that table, customer ID, package, and hours. So I use that sequence number so that I can read that table with a loop. Okay. And then we'll populate that table with the insert statements. That's just like what we do for a regular table. And then usually I got this commented out. Usually I'll read it back because I get it all in there. It's a good idea. Okay. Make sure you did populate it. And you'll note we got two nasty records here. There is no B package, and you can't have 730 hours in a 30-day billing cycle. They'll say change the clock. I haven't experienced that yet. I think it's not today, but
Daylight savings time.
no, that doesn't do me any good. Absolute time. Yes.
I thought when we use a cursor, we don't need that.
Actually, we don't. And I may have been doing something else there. No, we won't need it on a cursor. Because the cursor actually goes ahead and does that. And you just do it behind the scenes and you don't see it. Okay? And I did the same thing here. I was just a way of, and I may have been, it's also a nice way to identify my record, so that I know that, things came out in some kind of order, even though the numbers were not. And I had an out records table. I can't recall, did I ask you to do that too? Okay. All right, so I did that. And of course, we're gonna insert records into that on the fly in our in our big loop. Okay. Are we all good on that? Got questions? We can talk. Track these things up. Okay, then I did an error log table, and in this case, when we run into an error, we want to put out the customer ID, the package, the hours, some kind of message about the fault that you found. Okay. Questions on that? Then, next thing was to declare our cursor. And we're going to populate our cursor from that input table. Okay. A problem that we try. Normally you populate from a database, but you want to kind of work these table variables a little bit. Okay, and so, and then again, our cursor, our general practice here is we only need something that's static, local, and forward open. So we're just going to read from it, and then as we get the information, we'll actually hit the database, or actually in this case, we're not going to hit the database. We're going to populate our table variable, insert into our table variable. So we'll do that direct. And then at the end, we'll go ahead and do a mass update on a table from our output records. So this is our way. When we work with a cursor, we got to first of all declare it. What is it going to do? Okay. What is it going to look like? And then the next step is always to declare your variables that you're going to work with. And usually you're going to have at least a match with what you had in here. So we had the CID, the package, and the hours, and we had it there. And then of course we got the additional output variable, which would be the record, the charge or something. Charge. Okay. Any questions? on that. All right, and now we'll open our cursor, which really means go out and get the resources. And when we do that, it'll populate it with that query that we had defined in the cursor. So it's going to populate it with all the records in that table there. And then right after that, I like to print that out, see how many rows did I have. When a cursor is populated, this global variable gets populated with that result. So that gives you a feel for what that is. You don't need to, and what you're really, this is the only time you'll use it, is if it turns out that you made a bad query or something, okay, then it'll show up 0 and then no processing takes place. And you know no problem. Any questions on that? All right, now for the fun. Let's put it into that loop. Okay. All right, so this is our typical cursor loop that we discussed the last time. And first thing we have to realize is make sure that we fetch the first record before we enter the while loop, because we need to set that fetch status. That fetch status does not get set until I read at least one record. It needs to check the result of that. And as long as that status is 0, it means we had a good read, we move forward. It's when we finally read past the last record and it returns a -1. Now, the first thing we're going to do is do a little error checking. So there's no sense in processing this record if it's no good. All right. And so in this case, I used an if else. Normally I use the case, but I'm not sure why I did this at this time. Yeah, I did it. So it is kind of ugly. So you got to have all those begin end blocks. So this is the begin block for the loop. That's the whole loop. And now I'm going to take the first one is check to see if our package is not in this set. Okay, if it's not in that set, I'm going to print it out, and then I'm going to write it to the error log because it's not valid. I'm always going to be checking for, is it invalid first? And don't try to check to see if it's valid. You look for the exception. Okay. All right. And here we'll insert into the error log the values, and here's the values that I read, and then I'll just hard code the message in there. Okay. And that's the end of that.
What we use the not equal to operator to check the package?
Not equal. I don't. What this? That's what we're really doing here. What this is, when we do this in operation, that's a shorthand expression for is it? It's not this, or is it not that, or is it not that, or is it not that, which means equality. Is that? It's a. I mean, I'll come over here. What we're doing is we're checking. Okay, we're saying if. That's a nice shorthand. If and what have I got here? Package. The PKG. This is really ugly. Not equal, and I may have went into the C mode here. for us, it's gonna be like that. Not equal to, we got big A, okay? Okay. Oh, in this case, since we're using the not there, let's see, it's not that, and, yeah,
Just put enough for a renter package.
it's gonna be and on these things because, that's what we, we're reversing the logic on it. So, but I think of it as, on the and, it's gonna be and, wait a minute. Back up. If I didn't use that, I'd have to check to see if package. If it's, that's right, if it's not, that's not equal? Okay.
Yes.
And, yeah, but I gotta check all of those conditions. And,
That's C mode again.
That's usually.
and,
And.
and we gotta do that for all of those. But this is it's kind of, does it in a different manner. It really says, first of all, do I have a match in that set? Okay? And if I have a match in that set, then I got a good value. If it's not in that set, then I don't have a good value. So, if you're answering your question, you can do this, but you can see that it's ugly setup. You tried to do that?
Yes, I tried to do that.
So you can do that.
You had an or.
No, that was for hours greater than 720 all package. I tried to fix it in
Yeah.
one
Yeah, okay.
statement.
Yeah, because the or makes it everything.
Yeah, I've got it. You have to be careful. I have to, especially when you change, when you're doing the
No.
Okay. So if that's true, then the record's already bad. I didn't even bother to check to see if the hours are good because it's irrelevant at this point. Now one could argue, I could also check that too at the same time, even though the other one was bad. Yes, sir.
I have a question about using a case statement. Is there any way to use a case statement where it actually does a function, not just returns a value? In other languages, within a case statement, you can put functionality, but it seems that all you can do is return a value.
I'm not sure I understand your question.
Okay, let's say, basically every time I've tried to use a case statement, the only way I can get it to work would be if you evaluate and then you return an actual value. Then 1 or then 0.
Oh!
Is there any way you can actually get it to do like the insert?
Oh, the case that, I'm sorry, that's, I'm getting myself, I switch modes again. On the case statement, that's an expression, that's not a statement.
So like in other languages, you can use it.
You want to be careful. In other languages, it's a statement, not an expression.
So I was just
What
thinking-
the difference of that is, an expression has to return a result. Okay. In the case of
So you couldn't really use a case statement here then, because you want to insert.
yeah, I'm doing some side effects there.
I mean, I used ifs, but I was just wondering.
Yeah. No, you didn't mess up, and I confused myself when I said I might have used the case statement here. No, this is gonna be the better, I think the better construct. You know, because what we're doing is we're producing a side effect also. Yeah. And then, so what I did here is I opted, it says, if it's one of them, if the package is bad, I'm not even gonna check the hours. It's already bad, okay? And we'll just move on. Okay. Now, had the package been good, okay, then that would have evaluated the false. That is, the if condition there. Then I would check the hours, okay? And in the case here, then it makes a little more sense. Have the or, you know, if you're checking outside the range, but that's an easier way to do it. Okay. And then likewise, if you're outside the range, then you go ahead and insert into your error code. You think that probably answered your question? Okay. Okay, that you had. All right. Else, if we get past that, then we now we can move on. And I just you know, for some reason whatever I was thinking at the time, I printed the customer there just so I'm kind of tracking, you know, which customer I'm working on. And then here we're using this as an or condition. Okay? In this case up here, we were using it as an or, and then when you do the not operation on it, that really converts it to this format over here with all the ands. Okay? So this is convenient again, rather than I could have written this is a package A large cap or, but rather than do that, you take the shorthand because when we do an in and we do a listing like that, that's the same as a or. Okay? And we do,
Is it case sensitive?
yes, absolutely.
Because I ran it with all lowercase and came up with the right answer.
I think now too.
That's
Wasn't
because
finding-
okay, what you've done is, that has to do with the setting you have on your SQL server. You can set it for case sensitive or not.
Right. Okay, so
Yeah, you don't ever want
I
to
did it
assume.
here in it. Okay. I get
Yeah, they're set probably to be not be case
Default.
sensitive.
you. Okay.
Yeah, but normally you don't want to leave yourself open in your code and, you know, the settings are not right, and all of a sudden, you know, you get
Maybe you just converted all the lower character.
you can use, you can use there's a upper and lower conversion. I just kept it at the lower level. And then you gotta do the same thing for B, and you gotta do the same thing for, and of course, if it's not A and it's not B, then go ahead and do C. Do all your check up here, go from that to that set. Okay?
So if you use the case statement there, if it does match your character, then you insert the results, or can you insert the results after you check everything?
You can insert the results after you check.
Okay.
Yeah. And there may be a way to use the case statement, or somebody else use it. Who else use a case statement?
I used a case statement because I think if you say hours minus 50, potentially it would be a negative value, couldn't you?
Well, now wait a minute.
I used a case statement.
Oh,
You-
I'm sorry. Let me answer. No, maybe I misunderstood your question, Philip. What are you talking about?
Well, when I do my case, I just check every character, and then if it was a big A or small A, I do my computation,
Okay,
okay?
right. And what you do, is that, I think there's a, I'd have to look, I can't recall it, because there's a combination that says I don't have to return the result because I put it in that one. I'll say, if the when statement, I can go ahead and produce a side effect. That's what you did. But normally I don't do
I put it this way, it's probably the way I was trying to.
Okay, we're trying to do it and then get done. Okay. Somebody had a question on this one, on that, on the set statement?
No, I missed that you're checking to see if it's greater than 50 hours before you set your charge. I didn't catch that at first. But instead, I used a case
Okay.
there.
That's fine. There's more than one way to do this. It doesn't have to be exactly like this. And then here's where we, depending on the condition we had, this is where we insert into our outlet. And then this is your update. So, Stephen, this might be the place where you had that infinite loop, that's going to be the spot. But I assume you probably have that.
Actually, I was missing a begin at the very top.
Oh, okay. Okay, so it was, and it was, that was probably, got confused on that one.
Yeah.
That's interesting. Okay. Any questions on that?
You'll put that out there on this person?
I could probably do that.
Okay, then.
Just, use it for your personal use and responsibly. I'll have to read these. I usually don't have too much trouble with the class like this. Anytime C class.
Don't trust me.
And then it close out there. Okay. Any questions on that?
In and Norton has made simpler.
Yeah, oh, yeah. Yeah, you want to use that in collection operator if you can possibly do that when you're looking for, and it's based on strictly quality comparison. And if you have that, then you can do that. If you have to check ranges or something, no. And see the other was a little better. But it had to be a discrete set of things or not at all. Okay? All right, so let's start to look at storage procedures. And actually, this is not new coding as much as a way of formatting or packaging what you've already been doing. And you've been writing these scripts, and now it's probably more desirable after, if you get very, very large scripts, you want to start to break these things up into pieces and put them into little stored procedures. Not only that, we can store these things out on the database, so they're available. And so it's easier to execute these things even remotely from, say, something like a Visual Basic application or a C# application. Okay. And so this is the desirable way to write your scripts, rather than this monolithic type thing. These last couple of exercises. So let's take a look at these. I'm going to do a little high-level stuff with the PowerPoints, and then I've got some coding examples that we can go through and kind of illustrate and see things in the bigger picture. Okay, the syntax, and just the syntax diagram at the top. We use the keyword create. Now, when we create these stored procedures, the create statement needs to be in its own SQL file. And I'll have an example of that. And it needs to be in its own batch within that file, because typically after that, I'm going to have a little test script to see if this thing really works. Okay. And when I run that and it's successful, then it gets stored automatically. I've got to run it the first time to get it stored. Okay. And so I like to see, did this thing also work right? Or otherwise, I don't. Yeah, it validated, but also it could run and compile correctly, but and get stored, but it wasn't right. Okay, but if it has a bad compile, then you don't even get to run your test, because you're going to put that in its own batch. It's going to batch it. So we'll see that. So it starts out with the create, the keyword. You can use PROC or procedure most of the time when everybody uses proc. You know, that depends on where you are. And then you give it a name. And it's got to be a unique name, okay, within the database. And then parameter declarations, because you're going to be able to pass information in, you're going to be able to return information back out. We're going to look at those parameter declarations. And then then your SQL statements, just it says what you're going to do in here. Okay, that's the scripts you've been writing. Okay. And format. The next thing we want to look at is what kind of parameter declarations can we have? Well, they look just like the things we do when we create these variables. They're going to need an @ sign, it's going to have a parameter name, it's going to be a data type. We can also specify a default value. In other words, if we don't have the parameter there, then it will automatically assign a default value. The other thing is that this compiler has to distinguish between whether it's an input variable or an output. If I don't say anything, it's an input variable. But if it's something where I'm returning back, okay, then I got to put the keyword output after that. And then I can have these to be comma separated, so I can have as many as I like. I've got a couple of examples here. So here's a case where all we have is date variable, small date and time. What that means, it's simply an input parameter that accepts a date time value. Okay. Here, I've got vendor variable, variable character, and it has a default value of null. In other words, if I don't have a vendor name, vendor variable, I'm not sure what that means, but anyway, this is from your book too. Okay, it's an optional input parameter that accepts a character value. Then we have an output variable, and now we have to put the keyword output in there. And I'll have some examples in my little script. Looks just like our variable declarations. Got to specify the data type. I can specify a default value. And optionally, that's an optional. And then also is it an output variable? If it's not an output variable, then it's an input variable. Not to do anything. Okay. Most will be an input. And sometimes you'll have one output, sometimes two. We have it's optional. Depends on the application. And here's an example. And I've kind of got this, and then I've actually got the real one here. I'm going to run shortly. I got this. This is going to be my little ePay table. that I've been using. And what we're gonna do is I'm gonna have a little script that reads one record, given a customer ID or an employee ID in this case. And so, first thing I gotta do is check, because typically if I have something in there and I wanna change something, I'm just gonna drop it. So, here's the, usually the format that I use. Don't have to be that way. I think you'll find it easy to work with. Create, and I use the proc. And this is convention. Put a little SP in front of the name to indicate it's a stored procedure. That's just for your readability. Compiler doesn't care. We can read anything. Okay, and then instead of having stuff listed this way, I list them down because it doesn't care. It's got comma delimiters in here, so spaces don't count. So, and usually I put in my input variables first. In this case, I got one input variable, okay, and I got two output variables. So I'll read a record, and I'll indicate what record I'm reading, and then return to me the rate and the hours I'm going to use it. And so I return those through output variables. Now what you want to do on these should match what your data types that you have in your database, in your table. You want to get an exact match. Then the keyword as. Then this is stuff you've been doing. Okay. Except this nice simple query. We'll select out the rate and the hours from ePay for this parameter that I just got. Okay. And then execute that, then it gets stored on the database. It's already pre-compiled after that. Okay. The benefit of having a stored procedure, it's always compiled. It doesn't have to recompile it. Yeah.
So there's three underneath SP, read, ref, parameters. Where it says create proc.
Create proc.
Uh-huh.
Okay, this is the name of the stored procedure.
Right, and the three variables.
These
underneath.
three are the parameters.
So you pass those in somewhere.
Well, you're going to pass arguments to those parameters.
Okay, so how do you know, when you say where EID equals and EID, how do you know what an EID is if it doesn't have a variable set? Doesn't have a value.
This is this might be my stored procedure test. Okay, so here I'm going to declare three variables for my test. EID, rate and hours got the same. No confusion. That doesn't get, the parameters are local to the stored procedure. These are local to this batch. Okay, it's separate from the other batch. Okay. Set EID. This is the way I call a stored procedure. Got to use the word execute, the stored procedure. These are the arguments that match the parameters. Okay. So what I'm doing is I'm passing in a value here. These get returned and copied into it. Okay. Stored procedure copies into those, and that's these right here. And you'll note I've got to specify that those are output. I think they'd improved the compiler enough to realize, wait a minute, I already said they were output, but you got to tell it again. Okay.
Here, the rate, at rate and at hours, you didn't specify output, so are they considered as input variables? The previous slide was specified output.
the rate and the hours are gonna be output. Now, what we're doing is we're selecting, okay, from the database.
Yeah.
Yeah, so, then I'm gonna return these, to this other batch, into those, these variables, this variable, this variable.
Why did you get to declare?
Well, we did declare two types. This is the parameters for the stored procedure. These are the variables for my little test script. I could have made them something else, I just made them the same. I made them the same because it seems to make sense to me, and the thing is, it doesn't get, it's not confused because they're separate.
So we'll be passing only the, at EID as the parameter.
That's right. And you can actually, the argument actually evaluates to the 111 here. Okay? You're passing the value. And values will get passed back, copied back. Yes.
When you pass the parameter, when you call the stored procedure, do the parameters have to be the same name?
No, no. Have to be the same name, have to be in the same
Same type.
And same.
type. Yeah, they have to be the same type and position, yeah. The types have got to match all the way. Okay, so when we were looking at the stored procedure, the types here, you want to match those to what you have in your database columns. Because you're going to be, basically these are going to be, these are database table values.
So it's very similar to function.
Yeah, absolutely. It's actually a little more crude, but the language, this language is a little different than the standard programming. Okay, so let's, this is a good time to take a break on this one and go out. I've got this one out here already. So where's my, oh, here's my read. Okay. So, let's see. I may have to go out here. Just thought about it. I'll do, yeah. Let's look in the lecture database. And I've got the e-pay table out there. Okay, so I already have an e-pay table. All right. Okay, good. What you want to do is you look in here to match up things. And we got that matched up. I want to do that. So I'm going to go back and get myself. Okay, so step number one is make sure it doesn't already exist. Okay. Next step, you'll note this is in its own batch. And then the test script, which follows, is in its own batch. So what that means that this is going to get compiled and executed first. If that's successful, then the test script is compiled and executed. This will be stored if it was successful. And we'll go out and see where it's stored. It's there. Okay. Any questions on this before we cut her loose?
Recommended to define the stored procedure before we actually call it.
You have to define it before you call it, because it's going to go out to this statement here is actually going to go out to the stored area and retrieve that and execute it there. Live show, 11:11:4. Pardon?
Is there enough?
There you go, and take a look. Object Explorer. Okay. Let's close up that. The next should find something under programmability, stored procedures. Well, usually they'll say, come back and they'll say that completed successfully. You get something,
Yeah.
and I just didn't get that. Okay, now. But I'm not sure I believe it because I didn't get my printout.
Print it, okay. I bet I got the culprit here. All right, so let's go do something. Let's go take a peek. All right, let's find that. Basically, I bet you it's not 1, 2, 3. Okay, it just did nothing. Okay, all right. Select star from EVAY. And there's the culprit. All right, so let's I'm gonna take that. And let's go back to here. I'll do one more. Basically what I'm going to do now is I'm going to drop it and do it again. Everybody good with that one?
So do you need to drop the read directory?
I don't have to. I don't have to, but I'm not going to comment out my script. I'm just going to show you. Well, we're going to create store procedure and store it. So what I'm going to do is drop it to the one that's out there now and just do it all over. I would have expected that message to come up, and I think what happened was because it had that failure, it didn't, so I don't know. That was what it was, but what it did is it overwrote that. So let's go see if that. It didn't do that. All right, so that's usually what I do. And I run that test right afterwards, that way you know that it's correct. And then you can always go back out and the place you find it off the floor is you go under the database that you're in. Each database has its own set of tables, views, programmability, and inside the programmability is we have stored procedures, functions, database triggers. And so we drop down here, and then here's our stored procedure. Move on to some error check. One more thing. Return. We can actually have a return statement in our stored procedures Now, this is not to return data. What it does, it should be to return a status. Quite often, and the only thing you can return is an integer. So it shouldn't be misused by, I'm going to return, you know, because we have another construct to return data, and that's called a function. But what it can do is I can be producing a side effect, and one of the things we could do is to see if I do an update, did I get any records updated, because we can check a variable that a global variable, system variable, to see if we got it updated. So that way we could, that's like returning a status. So we can do the return. So I'll take a look at how we might do that. And I think I've got an example. I'm going to go ahead and do the other one with that. I think I got all this together in one batch, one script. The next one is raising an error. Now this one's going to be, this may be a little bit new for some of you. Raise an error. Okay. What we can do is, now you've already experienced errors that have been raised by the system. We can also raise errors in our script. In other words, and when we do that, the reason we want to do errors, raise errors, is that we can't resolve it in our stored procedure. So what we, pardon?
Just read.
Okay. Then we'll return it back to the calling program to let them resolve it. But when we do that, then we now have to have a way of handling that and catching that. And that's what's referred to as a try-catch construct for doing that. So we're going to look at that. And we'll look at an example of how to create our own error messages. So usually we'll have a message, and then this severity and this state stuff, we've just got some standard numbers that we use. It's always 50,000, that's a custom number. You don't get to assign any of these. And I always assign it a 1-1. So our stuff is mainly due to some kind of logic error or some kind of a validation error that we can't handle in the script, but it can be handled by our program. It's not a system type stuff. So thing is that they've got it set up is that if you want to use this, you want to play, you got to put that 50,000 and that 11 in. So we'll just go along with it. So I got an example for doing that. So here's my little example of raising an error. Okay. And so this is the case where I had the update here. Okay, so here I'm going to use my stored procedure to update a record. But I need to know, did it get updated? And if it did not update, the number of rows that got updated get put into this system variable called row count. So if I had some kind of an error like I had in this other one, if I'd have been trying to update record number 1, 2, 3, well, so this procedure would have ran and said, fine, thank you, you're doing great. But it doesn't, on an update like that, system doesn't throw an error. And so you have to test it, and then you raise the error. So in this case, if we had an invalid EID, that would be the one that would create the problem. Then I wouldn't get something that was updated, so it would be a 0 in our row count. The other thing is if I was expecting to only have 1, and I got more, then I got another surprise. Okay. So I can return that row count. Okay. So our procedure will be I'm going to update, and then I'm going to declare a when we do this row count here, or when we have a row count, this row count ballot variable gets changed on every operation. So what we want to do is that right after the update, we want to be sure that we capture that value, because the next operation will change that. Okay. So it's just capturing the results of the last operation. Okay. So here, then we check to see if it's 0, which is, means we didn't get an update, then we'll raise an error. And here's my statement here. And, well, we don't have to put the 50,000 in. It automatically will put the 50,000. I got to put the 11 and 1. That's fine. And I got it highlighted in red. Just put it in so you can play. Okay. And then return it. So at the bottom of my stored procedure, I'm producing a side of that, but I'm also returning this value. Okay. You can do that with stored procedure. You can't do that with a function. Don't do that. We'll let you do a side effect. Okay.
I have 2 questions.
Okay.
One is that 11.1,
Yep.
what is that actually? I mean, I assume the 11 is the error that we are creating?
No, no. No, it has to do with system settings, values, and the 11 to 19 is the severity level, and then the 1 is the state, and I don't have that in here. I can't recall what that was. Basically, we don't use those. Those are only for actually system type errors, and we're not producing that. We're using this as kind of a way of saying we have something that happened inside our stored procedure, and we can't handle it. So what we'll do is we'll allow it to return to the calling environment, the calling script. So, and what you're required is that you got to put a severity level in there, and the 1 is the lowest level for the state. 11 and 1, that's as low as it gets, and it doesn't do anything other than let you compile.
So we're never going to use anything other than the 1?
We're not going to use anything other than 11 and 1.
Oh, well, it said we could use from 11 to 19.
Yeah, if you want to. I'd use the lower one.
All right, so always use the 11.1.
Yeah, because it doesn't mean anything.
All right. My second question is, what is the as for up there? Create proc as?
Okay, that's the syntax. Okay, it just simply says, I'm going to, this is going to be creating the procedure to execute this script. If we go back, there's our syntax. As. And then as soon as it has the as keyword, then you have your SQL statement that follows.
That's a peculiar word to choose for that.
Well, it's particular in this language. It'd be similar in our other languages to indicate set of parentheses or set of braces. Just simply says after that point, then the SQL statements are going to be the statements that describe what you're going to store in that machine.
Okay. It's just a strange thing
No,
to say. I'm wondering what their reasoning was behind that.
Well, they're gonna have something there to indicate when you're gonna start the SQL statements. That's the way those.
What was wrong with a parentheses or a curly?
I have no idea, and they've never used those. Okay. I think we've seen it. I think we'll see the ads again in a couple of other places. So, it's just get used to these particular syntaxes for finding. All right, now, when we raise an error, then the calling environment has to use this execute statement in what's referred to as a try-catch block. And what the try-catch block does is it allows me to gracefully capture this error and then take some kind of action. We'll look at an example of that. So it's always going to be this begin try, end try, begin catch, end catch. Those go together. So our execute statement would be in where we have the SQL statements or block that, it's going to throw the error. And this is going to be the block that, we handle it and do something with it. Okay. And the error that we receive can be interrogated with these 4 functions. And they can interrogate that state severity. That's the ones we created. So that'd be the 11 and the 1, not very useful. What we're really interested in is this right here. If we ask what the error number is, everything that we create is going to be 50,000. Okay. The system is the only one that assigns numbers, error numbers. And the only thing that's really of interest to us is this anyway, that message. That's usually the only thing we're looking for. And usually we know what to look for, because we know what to expect. Okay. Let's take a look at see if I've got that. All right, so here's my example of the try catch, then I'll go run this in a real script. So here's our stored procedure we've created, and since we have this potential for being invoked, and then up here we're going to have to put this into a try-catch block if we want to catch that error and then do something. In this case, I'm just displaying it now. We'll have other students. So here, I got to have some variable to capture that. And that syntax is not right there. I'll correct that. I think we'll see in my script. That's not correct. Okay. But we have to execute this and return the value into this variable. And now we're going to check to see if that variable is 1. If it's 1, that's what we were expecting. A good update. Because we updated one record. Okay. Otherwise, we'll just put the error message down. That's the block. So we'll go back here and where's mine? I've got page 2.
There. All right. So I've got a new stored procedure here, and this is gonna, the purpose of this is to update, set the hours, change the hours for elected anything. All right, so, first of all, we're gonna create stored procedure, and then here's the stored procedure. There is no output variables here, because we're producing a side effect. So we declare our variables, and there's our update statement. Then we'll check afterwards to see did I get one record update. And then we'll go ahead, if we didn't, then we raise the error and then return. Here, okay, so here's the correct syntax. It's not the set statement that I have in the PowerPoint. Okay, it's execute, and then I just simply have that return code variable assigned to the update. And so we've got 333. I think that was a good value, wasn't it? Yeah, 333. So this is going to be a successful one, and then we're going to go and then attempt to do one. All right. So I'm going to put this in a try catch block here. Do our test. Any questions on this?
So basically, try catch block here, in case we want to check whether we have that record in the list or not. So
Well, what we're interested in this case is that if we get an update, and if we don't get an update, then there's a pretty good chance we didn't have that record in there, okay? So what we want to do is we want to do the update. That's what we're checking. Did we successfully update? All right. Go back up here. And let's go ahead and execute. Okay. We had a good update. So as I go back out, let's go look at that Object Explorer, let's make sure we go back and see. I got to do a refresh on this. We'll do a refresh, and then they'll go and see I've got that update. All right, now let's go back, and now this time I'm not going to. I'm not gonna go ahead and do this. I want to do that. I'm just going to go ahead and block that out. Okay. All right. Now we'll go down here to begin try, and now let's try to update record 1, 2, 3.
2, 2, 2.
Huh?
You want one that doesn't
I want to
exist.
get a bad one in here,
okay.
so you can see, yeah, this really does work. Okay. So what, now we're gonna attempt to do an update. Because this should give you a flavor for why we raised the error there. I can't do anything inside that stored procedure. So all I can do is report back, said, I didn't get this updated. That's because I got an error, and so, I can't fix that error or correct that in the stored procedure. So in here, now we might have something that would, write that to a log file or something like that. Because, usually we just put some kind of message out. We're executing all of these just like we did in our little script. Except now we just put those error files, and then you go back and say, here's, let's fix these and then rewrite.
So now we'll execute it. Now this has already been pre-compiled and everything. All it's gonna do is go and materialize it from the database and execute it. Okay. Attempted invalid update. Yes, sir.
So in this case, there's only gonna be, it's either gonna be a 1, because you did 1, or a 0.
If we have primary keys in there and then we're updating on primary keys. If I had multiple records in there with the same key value, and I thought I only had one record in there like that, then I would see other numbers. The main one usually you're looking for, did I get anything up that? But you were correct. So normally that's what you want, because having those multiple things in there is those are not desirable.
Well, I just don't, I mean, if you were updating 3 or 4, you couldn't say equal to 3 or equal to
Oh yeah, right. Because here I'm looking. Let's take this a step further. Let's suppose that we called this from another script. Okay. And let's go look at mine. I've got it.
Professor, before you move from there.
Oh, sure.
What's the 55? Is there another?
That was the hours for the update.
Oh. But you don't have to contain them in
No.
the
No.
procedure?
Sorry, Richard, offending your sensitivity, but it's the way the language is. Yeah, no. What we have to have is if they're output variables, then we got to have output after it. Okay, so it is different than your other language. Okay, so let's. I've got another. Okay, here, update 3. All right. So here I have here I have a stored procedure, and it calls another stored procedure, but this stored procedure can raise an exception. And the implication here is that if I call a procedure that can raise an exception, and I don't do anything in here, then it keeps going back up the call chain. So it's going to go back to my original script. And at that point, I need to have the beginning of the try block. I could have had a try block in here if I could handle it in there. But typically what you do is that you roll these things up to the highest level where you have the most control. And it's probably usually going to be some kind of script processing at the higher level, and that's where you would write the error records. And that's typically the way we would handle this. I just did a little print statement. Okay. So it's just to demonstrate to you that, yeah, it does roll back up. You know, it just goes ahead and says, in the case here, this through the error, it says, okay, you're not handling it here. I don't know what to do with it. I'm going to pass it back up. Okay, so then it's going to go back up to this script right here. Okay, in this case, I've got to have this in the try check. Okay, and in this case, I'm going to demonstrate the error. So, in this case, it'd be okay. So, we'll change this so you can see that, it's gonna fail. 1, 2, 3. I'm gonna try to do the 1, 2, 3. All right. Do that. This is all in its own batch. This is a real simple one. 2 inputs. We're just passing through. Is all we're doing. Okay. And then here's a test script to see does this work for me. I'll capture this error. Interrogating the error. So let's go ahead and execute this one. And there we go. Got stored, and it also ran my script correctly.
Right, I missed the difference between the two. No, between the last one we just went.
Okay, what this one does, Rick, is this one simply calls the last one. The last one we did was update, but it called the SP update 2.
Oh, you've got a new one called, that's all you did?
Update 3. Update 3 calls update 2. Update 2 is the one that raises the error. Pardon?
It's something like a nested.
Well, it's not, well, you think of it as nested, but you want to think of it that way. It's just a procedure within a procedure. The point that I was trying to get across here is that if this raises an error and I don't handle it in here, then that error gets passed back to the one, to the calling program that called update 3. And the script here is the one that calls update 3. Here I've got to catch it, or the system handler is going to come in and give me that nasty message.
Is that from the state that we're setting?
Pardon?
What, how does it know that?
How does it know what message to put?
What message to put was what I have in here. Where is it? Attempted invalid update. Or,
Oh,
okay. There's update 2, which is stored up there. You know, I created that statement. Is this one clear for everyone? Sort of?
Should they both be in the same database?
Yeah, right. Yeah, it has to be the same database. All it's doing is if I have, you know, I'll just draw maybe do a little picture here. So if I have here we have I'll call a calling script, okay. The highest level program, and if I call a procedure at the next level down, which we call update 3, but update 3 calls update 2, and this is the culprit that raises the error. Okay. If I don't handle that error in here, okay, then it goes back up to here. And the reason I won't handle it here is because I don't know what to do. I could handle it there with a try-catch block, but I don't know how to handle it there either. Okay. So it'll go back up here, which is usually the place where you handle these, and those are at the highest level, you know, the beginning of the, you know, the top level script, because that's the place probably where you would be writing, writing your error records. You go back to where you write your error records. That would be the way we would, you know, in our updates, we would be, you know, we would be, our begin block, I'm sorry, our begin catch block, we wouldn't be writing, you know, print statements. We'd be capturing that just like we did in the ISP script. So that they're making, you know, say, look, we got some bad records here, somebody will fix it. Okay. Yeah. Clear for everyone?
You'll put these out.
Oh, yeah, they're already
Just
out
so,
there.
well, that way I can see side by
Yeah,
side.
yeah, they're already out there, I think.
They're out there.
So,
I think that's the way.
yeah, so, yeah, this is probably a little bit of a strange concept for you. And then if we had multiple things we have our catch it, you know, I'll try to see if I can work that in next week, and that we could roll back transactions. That would be another thing we would do. See if I can, you'll realize this is, you know, for some of you that maybe got a couple of people that had programming in here, and this is not new. But, I mean, you do that. C#, I mean, yeah, and try catch. So, but if you haven't, then that's awful strange, but that's the way to handle this thing. And typically, what you handle in there, in our case here, we'd write it to an error bar.
Did update 2 set RC to 0?
Yeah, if we go back right here. Here's our update too. I've got it locked out, but here's our, you know, it said, well, what it does is it captures, RC gets captured in that row count. And so if I put in a bad identifier, then it didn't get updated, so that's where it got set. It got set to 0. And so I said, if it got set to 0, okay, which means I didn't get an update, then I'll raise an error. See, this is the thing this is the trigger that, you know, that fires it off. And what that means is that if I don't do anything and my scripts don't handle it, then your system handler handles it, and then you can't do anything with it. But what we want to be able to do is to let it go back to I refer to it as the highest level script, where he said, oh, I've got, you know, because that's where the input came in from. I'll just write my error record out now in the catch part.
And then that just keeps it organized,
Yeah,
everything's up
yeah,
there.
yeah, absolutely.
Not buried.
Okay. Questions on that?
Please go to the update 3's calling screen.
Update 3. There we are.
So, like when we pass 1 to 3, so as you said, from update to that handle, so we come to the calling script. So here the error message is, this error message procedure again will go and get called from the other script.
Actually, what happened, this here is, what we say, we captured the error in here. Okay. That's what we refer to it. So now that you know, when an error was raised, this function on the last error that was raised, that's where I captured that message which we did right here.
So it will go again call this and
Yep.
this. Why is it that name same as every message and
why is the error message in here?
Yeah, why is it?
Because
the same?
I don't know what that error, if I have this here, I don't know what that error message is gonna be. What it does is when I raise an error, then I've captured that. We could say that, you know, we return that error, and I can, if you'll recall from our PowerPoint, this is, we'll these up, that when I raise an error, what I have is I have 4 functions that can tell me what that error is about. Okay. And when I created that error, you'll recall that I had the error message in there, and I had to put in the 11 for the severity just because I got a play. I got a 1 there, so I don't even care about that. Also, I don't care about this because all errors that are created by our scripts are going to be 50,000. So what? The only thing that's meaningful is this, and I can read that. Okay. So if I got another kind of an error, then, you know, whatever that error is, that function's going to have it. Yeah. Just think of it as if you know, toss the message back. You like to think of it. And I can interrogate what that message was with this error message function.
Oh, from the bottom level, and then you just, the error message keeps popping it
Yep,
up?
yep, it rolls up. You can think of it as why I say you think of it as we pass it back up. If you, I don't know. It's not going to be the same, quite the same concept as the object-oriented language, but it's similar. You can think of it, I generated a message down here and this one right here, and rolled them up there. So what was the message? Well, I'll read it from, I'll get this function. It says, what was the message?
Be a case where there might be more than one error.
Pardon? Yeah, I could have 4.
So it'll just be
Right.
another error.
Right, whatever, well, actually what I'm back to is that I'm only going to get 1 error, but I could have a situation where I don't know which error I'm going to get, because as soon as 1 error is thrown, then that's it. I'm not going to get another error thrown. Is that your? I'm not going to get multiple errors thrown. Because as soon as I have 1, your program is basically in termination mode. Okay. Okay. It's gonna keep looking for a place to go. Okay. And if I have a try-catch block, then I'm going to catch it. If I don't, then bad things happen.
You can define multiple errors.
Yeah.
So you can find 1 error, if you look at the 0, it's this. If it's 2, it's that.
Yeah.
And whichever
It's gonna
one hits
return
up
whichever
first,
is
it's
Yeah.
gonna
matched.
stop.
Yeah, exactly.
You said that the error number is always going to be 50,000?
Yeah. It's irrelevant. That's it. I think I got it.
Yes, I saw something like that in there.
All right. I'll let you digest that with, how will you? Huh? Okay.
So the raise error, you say is 50. So whenever we call an error message,
Okay.
so whenever we call that error message, it goes back and connects.
No, it doesn't. What you can think of, and what happens here is, if I look here, if I, and it, this is a logical view of it, okay? It's not necessarily the way it's if this condition occurs, I raise an error, okay? And you know, if you want to think of it, essentially, it gets put into a global storage area. Okay? And then it says, it immediately terminates this script.
okay? It goes back to the calling one. So in this case, that got generated down here, okay? And what we can think of is that there's a, some global area here, and when I raise an error, that message is in here. Okay? All right. I think of it, yeah, it's looking for a try-catch because it's
Nobody knows what to do
yeah,
until you get there.
right there. And if I don't have a try-catch block, then there is a try-catch block by the system. Okay, and that's the undesirable outcome. You can't do anything. But the idea is that if you have it in a try-catch block, then in the catch block, I can not only print out the error message, but I could also write all of my stuff to an error file. That's what you can handle. Okay, you don't just say, oh, by the way, you screwed up. Let's move on. No, wait a minute. Okay.
So once you raise the error, it's like the big flags.
Yeah, exactly. And the reason you do that is because it's a nice mechanism because I'm not able to do that because I can't change that here. I can't change that here. I can change it up here, only indirectly is here I've got the mechanism to write to, say, an error file in the context that we have. We don't have this interactive environment where I can, okay, enter a new value or something, and say, okay, that's a bad record, put it out there, and somebody else can do the job of figuring it out. Okay. You're all good on that, sort of? Okay. Okay, let's look at functions. Okay, they're like stored procedures. Except they have a little more flexibility. And a function can return a data value. Now we're not talking, when we talk about the return on a stored procedure, that was simply meant to return a status. Okay, you don't usually return data on that. So we're going to talk about a scalar valued function. That means I'm going to return a single value. Next week, I will talk about returning a result set for the table value. Okay, we just kind of take this one week at a time. Okay, so I use the keyword create function. It's going to be a little bit different syntax. And it has, I'm going to give it a function name. It has a parameter list. It has no output parameters. Okay, you can't return outputs on these because you're going to be using these in an expression. And in fact, you can use functions in declarative statements as well as procedural. And we have to tell it with this word here, returns, and the type of data that it's returning. Okay. Now, what is the action here? Okay. Here, in this case, the as is optional. What is required is a begin-end block. Okay, and here's my SQL statements. And I have to return some value that matches that data type. And then I can use this in an expression. And an example of that would be calculating the pay for our e-pay table. This is a really good example rather than using that as a stored procedure. So here's an example of, now I've got a little function, I'll pass it the rate and the hours. I don't need to pass it the ID, I don't care. I've already got that. I just need the calculate its pay, and then go ahead and do an update. So here we go. Create function. Now, as a convention, we usually precede it with the FN for function. That's so that, you know, if you got that in your program, you can say, yeah, it's a function. I'm going to pass two parameters. We're going to take two arguments, the rate and the hours, because that's what's needed to do the calculation. I'm going to return a decimal 5-2. Two decimal places, no more than 5 digits. And in this case, I use the optional as. And then begin and end. Now, typically, when you've got to return something here, you're going to create a local variable to populate it with your statements. So typically, your function statements are going to be more procedural constructs. Stored procedures also can be procedural, but you know, here we're strictly procedural constructs, and we're gonna put all of our heavy-duty statements in here of how to compute the pay, and then we'll populate this pay variable and then return that value. And we'll store it. So the syntax looks similar. It's going to get stored just like stored procedure, except this is a little more flexible in that it can return one value, and it can be used in an expression, which gives it a little more flexibility. A stored procedure can only produce a side effect. This cannot produce a side effect, and in fact, I cannot use an update statement in here. If I try to use an update statement, the compiler is going to catch me on that. Okay. Here's an example of how to use it. What did I do? All right, well, I see, okay. I looked at the SP there, and okay, I'm doing two things here. I'm going to use read record and get the rate and the hours, and then I'm going to go ahead and pass the function. So I gotta put all this stuff together now. So got a little script here with the EID, rate, hours, and pay. And we're going to do this for ID number 222. So the first thing I'm going to do is go execute my little read record and get the rate and the hours for that employee. And then the way we use the function is in an expression. I'm going to set the pay here. Okay. Now, on your desktop, when you call a function, it needs to know the schema. And so it's always, for you, it's going to be DBO. That's the database owner. You're the database owner of your database. Dot, financial calculate pay, and then you pass the arguments. Okay, and then we'll print it. And we could also just call that function right in an update statement. Any questions on that? No, I got a little script here. No problem. See it? Yeah, I'm gonna go do that. Okay. Good job. Thank you. Let's do this. All right. So. I don't think I pulled that in. All right, so let me go back. Let's go back out here. Function, calculate pay. There we go. Open. Function, calculate pay. And first I'll check to see if it exists. It shouldn't. And then here's my
here's my function, create function, calculate pay. Oh, now, just to mess you up, here we got parentheses on the functions.
Yay.
It's functions, yeah, right. Okay, not a stored procedure. All right, so we do have the parentheses on there. And then we gotta have the returns. And then I put the as in there. Not required, but the begin end is. Okay. And usually whatever we do in here is going to be something that I'll populate some little local variable, which we return that value back. And then here's my script, which is not going to fly. We don't have such a piece. We got a 222.
Yep.
I think we've already updated the other one. Okay, so we want to show that we're doing this. Okay, there's my read. Okay, that's a stored procedure. And then once I get this back populated in those variables, I print it out so I can see, yeah, and then I'm going to pass them into here, and then print the feedback. Calculating the function. All right, so let's execute that. Wow, life is good. Okay, so there's our rate, and then there's the hours, and then there's the pay. And if we go out, view, and look at the Object Explorer, programmability, let me refresh that. And here, I've got to look under functions, and there's two types of functions, the table value and the scalar value. Next week, we'll look at table value. Scalar value, there it is. And I'm listening to the DVL on this, so I got to call it.
Calculate pay for a couple of then
You
in a loop.
can do it in loop. Now you take this. You would take this script right here and put all of that in a loop, and then you enumerate through your records. Or you could do that with a cursor. You're reading ahead, but that's your homework problem.
And that is
Yeah, that's what you're gonna do, yeah. Yeah, you're not gonna do one, I'm doing one here for explanation, okay? What? All right.
I have a question.
All right.
Why now do we have to do video?
You know, I don't know. I don't have an answer for that. It seems to be required on this desktop. You know, in other words, if I take it out, delete. Okay. If I take it out, let me do something. Let me close this up. Okay, let me do this. I don't want to drop that out of it. So I got all of that. Now let's go ahead and attempt to execute. It says, not recognized as a built-in function name.
You say that's just the desktop? Because I noticed in there that that DBO, you can set it to other things other than DBO.
Right, if you have schemas on,
I haven't read up very much on the schemas, but I just know that, and I was going to ask you about that because there are other schemas you
yeah,
can
right,
use.
but you'd have, those are the ones you define.
So how does it know?
But I don't think on this one, on the desktop, you're gonna be able to do that, because what it really does is it defines owners.
The store procedure.
Yeah. Of course, I don't have a good answer.
Okay.
I would not, I thought we would have to do that.
No parentheses, no detail.
Huh? Pardon?
No parentheses and no detail.
Well, yeah, okay, on the store position. So if I go and do DBO, and I think I discovered that, because I probably, the first time I did this, I just did function. And then I thought, and then I looked at the way it was stored in the tree structure, that we go out and that tree structure.
Could it be that it's executable?
Well, both of them are executable. Okay. But if I go and look in the stored procedures, are in DBO too.
Everything's
It could be,
DBO.
you know, how you're calling your other function, the error message, that function. If you don't have the DBO in front of it, it knows it's a built-in function. It's already defined by the system, whereas DBO defines it as a user-defined function.
Thank you. That makes sense.
Or why not? The procedures.
Procedure is defining the variables used by the function. That raise error, there's error message,
The system
system.
function.
Well, there's system level stored procedures.
Yeah, I mean, but she was asking about in the script where we did the raise error. You're defining the error message.
Oh.
You're defining what that error message function is going to pull. So you're basically defining the variable.
I misunderstood her. I thought she was saying, why don't I have to use DBO?
I was, but
Okay.
I understood what you're saying, but, no, I was, mine don't know. Yeah.
You know, I don't have a good I don't have a good answer for that.
Okay.
It doesn't, because there's also system
You know,
level.
but the stored procedure, you don't use the parentheses. Whereas the function you do use.
That might be it because of the
Error message
syntax,
uses the
yeah.
parentheses, which
It has to do with their
defines it as a
parsor.
function as opposed to a procedure.
I'll hide
Did
that.
you-
They can probably fix that, but they're not going to. Do you have a
Sounds good.
question?
I'll go with that.
But it's a short of how you define a function. You don't need to say parentheses. Here, the variables.
But you don't have stored procedures in C#. You just have that as a function.
No.
You can have functions that have side effects.
Well, you do have, no, you do have some stored procedures, like to close a form, there's a close.
Okay, you
function.
got those things, okay.
Yeah, so-
I don't think we will. All right, let's look at us. We're gonna revisit this problem. Now, you already have the code for it. What I want you to do now is to take what you did before, and so you get a feel for, you wrote that as a one script. Now, do that with stored procedures and functions. And I've got,
Can that be program 11?
Yep.
Yep.
Dave's right this time, but the program number isn't. Save, all right. Stored procedures.
It is programmed in.
Okay. All right. Here is the suggested, now I'm gonna allow you to, I have, let me do something here. This one needs to be a stored procedure because you're doing a side effect. This needs to be a stored procedure with error checking. And then you got something here called do payroll. And that's gonna be the thing that calls all these other functions. And we could change this to function. And we could change this one to, because we're returning one back. So we get a little mix here. And we'll change this to a function. Reading the record, we can't, because we're returning two things. Okay? But we're returning, calculating the bonus, calculating the commission, calculating the pay as one item. Update, can't update to the function, so I have to use a stored procedure. And payroll, again, you're producing a side effect. Side effect meaning I'm gonna be, each one of these applies to a record. What you're doing here is do the payroll. Let's do the whole table, okay, with all of these in a loop. Whatever you like. I'm going to give you a little more creativity and flexibility. If you wish to use cursive, probably makes the most sense. So it's probably going to look like an overkill for this little script, but you got to start small or otherwise it'll get wrapped around. Any questions on that? This will not be the last big program. And then next week I'll probably have some little thing. Otherwise, won't need any of that stuff. Some little thing. You'll have 2 weeks to do it. All right, let me put that out there. Go back to the top. Yes, I will do that. I've got the better reading. One. I gotta close this. Copy. And I. This is going to be in the go out here, ISP script, copy. Again, back to your personal study. I'll put that in the curses. Okay. ISP script.
Okay? Have any questions, I'll be happy to answer them. I'll be in my office, stay here and work.